Good morning, everyone.
Good morning.
One more day. And then what? One more week? One more day and one more week, and we're done for spring break? Yes, I am right. We have eight. We have eight today. Good, good. All right, so we'll go ahead and begin. Let me share my screen here. We are on partitioning a segment, Keeper 30. Keeper 30, partitioning a segment. Carla, are you ready?
No.
Yeah, I just woke up, so I'm
10:30.
I know I went to sleep at like 30.
Why?
I don't know.
Well, I'm glad you got your rest in. So this will be fun. This is actually a unique segment. No, that'll play on words there. My mistake. A unique keeper, partitioning a segment. How many segments does the midpoint have if the midpoint does have segments? No, that was just a joke. It's how many segments does the midpoint split a segment into? That's what we're looking for today. We remember what our midpoint formula was. We learned that back with our distance formula. But we want to know now, are these segments equal in length? Because if they are, that's a ratio called 1-to-1. But guess what? Not all ratios are 1-to-1. Sometimes you might want to divide something in a ratio of 3-to-2 or 5-to-1, whatever it is. And that's what we're going to learn today is how to do that. Partition means to separate or divide. A line segment can be partitioned or split by another point into a given ratio. So 1-to-1 means the segment was split into two segments of equal length. So if you had a segment of 10 and you split it in equal lengths, each segment would be 5 and 5, right? That's a 1-to-1 ratio. But what if you wanted a 2-to-1 ratio? So this is how we're going to do this. For other ratios besides the 1-to-1, it is necessary to determine the total number of parts that a line segment must be divided into. For example, to determine the point that divides the segment AB into a 2-to-3 ratio, the segment must be divided into 5 equal parts. And they get that because they added the ratio of 2 plus 3 and they divided by 5. Okay? So this is not too complicated at the beginning. It does get complicated when we put things diagonally in on a graph, but let's just look at an example of a particular line. Let's say that point Q, and this is where I'll need my handy dandy stylus that doesn't always work. Let's go green today, everybody. Let's try a little green. Okay. So I feel like Bob Ross and I'm painting a picture, but P is at 1 and Q is at 7. So here we have P and Q, P and Q is at 7. Now we want to find the point T that partitions P to Q into a ratio of 2-to-1. Okay. Well, let's look. How many positions are there between P and Q? Well, here's 1, 2, 3, 4, 5, 6. Okay, there's 6 lines or 6 individual segments between P to Q. And it's a ratio. It's a ratio of 2-to-1. Okay, so we just saw if we take that 2 and we add it to that 1, we will get 3. And there's 6 segments, so if we take 6 and we divide it by 3, we get 2. All right, so now we can divide each segment into 2 equal lengths. So here's 1, here's 2, and here's 3. Now, it's asking, where does point T go? Well, here is one section, and it's a 2-to-1 ratio. Here's the other. So point T goes right there, right here at line 5. There's a 2, here's 2 to 1 ratio. Does everybody understand that? Because understanding
Yes.
this will definitely help us get to the next segment. Carla, you look like you're spinning around there. You okay?
No.
Are you in a what are you in, a washing machine?
No.
What is something spinning, or is it just the way the camera's going?
I know, right? I was like,
It's probably just the camera.
No, it's like lights are
No,
going up.
it's your lights in the background.
Oh, yeah.
God,
Those are just my.
oh my God.
that was creepy. I thought you were spinning. Now I see what it is.
Oh, no.
Good, good. All right. So that's the way we partition a segment. Let's look at another one. What about this? I'm gonna change colors on this one. All right, A is at a -4. This is a line A. And B is at 10, so it's 9. It's way down here at 10, okay? And this is B. And it's asking find point P so that P partitions B and A into a 3/4 ratio. So how many positions are there between A and B? Well, let's just add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 individual segments, 14 moves. We'll say 14 moves to get from A to B, okay? I guess that's probably not a best word I can think of. And it's a 3/4 ratio. So that's 3 plus 4 gives us a total of 7 equal parts, okay? 7 equal parts. So if we divide 14 moves by 7 equal parts, we actually get 2 moves per part. Okay, so if we move 2 times, here's 1. I don't know what that was. Let me erase that. That's horrible. All right, and I'll just do it in red. So here's 1 segment. And then here's 2 segments. Here's 3 segments. Here's 4 segments. 5 segments. 6 segments. And 7 segments. All right, and it asks us to divide into a ratio of 3/4, so that way point P will be in that ratio. So we just need to find the first 3 ratios, first 3 segments. 1, 2, 3. So point P is going to be right here at 2. There's our point P. There's 3 segments, 1, 2, 3. And then we have 4. 1, 2, 3, 4. So we have divided segment AB into a ratio of 3/4 and put point P at item 2 or number 2. Okay? Any questions before we move on? All right. Good, good. I'm glad you are understanding it. All right. So now what if we put it on a 2-dimension graph and we actually have to plot this and find the segment? Well, here's how we do that. And this is what you're going to be doing today or learning today. Given the points A is -2 to 4 and B is 7, -2, find the coordinates of the point P on the directed line segment A to B that partitions it in a 1:2 ratio. The first thing we do is we would graph the points and draw the line segment. I mean, that's just standard, right? That's the easy part. So if we were taking a test and you did that, you would get a point. Great. So here we've done that. And now we want to determine how many pieces you are partitioning your segment. Well, we're going to partition the segment into 3 because it's a 1 plus 2 ratio gives us 3 segments, okay? So we got 3 segments there, okay? Then we want to determine our slope. Oh, that's the tough one, right? Do y'all remember how to do slope?
Yeah.
Rise over run? Well, we can just look and add it, right? I mean, if we go rise, we can go down from A to B. And so if we go B over here, we can say it's 1, 2, 3, 4, 5, 6. So our rise
Overrun.
6, and our run, I want to say, is 9. I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9. And our run, rise over run, ruin, I don't know what's that, is equal to 9. So 6 over 9. Now we can reduce that to be 2 over 3. Guess what? That is the slope we are going to use. All right, but hang on. So it says partition your slope. Use your new slope to partition your segment. So what that means is I'm going to go down 2 because that's my rise. I'm going to go down 2, 1, 2, and I'm going to go over 3. 1, 2, 3. And that puts it right there. So let me put it instead of blue, I'm going to put it right here in red. There's my first point. And then from here, I go down again. 1, 2, and I go over 3. 1, 2, 3. And there's my second point right there. And then from that point, I go down again. 1, 2, and I go over 1, 2, 3, and I'm back to my B. So I have 3 equal segments. 1 segment, 2 segments, 3 segments. Wait, that's not looking right. Hang on, I just got to erase some things. Don't worry, it's right. I just don't like the way that looks. Now you can see that these are equal segments here. And it's asking us, and then it says, now, if we don't use a graph, you can add the new slope values to your starting point. And our new slope, so we're trying to find that point, right, of a 1 to 2 ratio. 1 to 2. A is the 1, B is the 2. So right here is my new point that partitions this to be a 1 to 2 ratio. And that point is 1, 2. 1, 2. Do y'all see that? It's right there. 1 over 1 up 2. 1, 2. Now, let's just remember that 1, 2 is our point. Now, she says that if you do not use a graph, you can add the new slope. Remember, our new slope was 2 over 3, okay, to your starting point to determine the partition point. Well, negative 2 plus 2, that's not going to give us 1, but that one doesn't really work out very well, does it? 2, if you do not use it, you can add your new slope values, which is 2 over 3, to your starting point, which is negative 2, 4, to determine the partition point. Negative 2 plus 2, that'd be 0, and 4 minus 3. Oh, that's right. Sorry, I'm using the wrong numbers. It does work. Sorry. It's rise, which is rise is my y value, and this is my x value. So 2 plus 2 gives us 4, right? And x is our x value. 1 plus, I'm sorry, 1 plus, or 3, it should be minus, gives us a negative 2. All right, we'll look at another one. I'll show you how it works perfectly. Let's look at this one. Given the points, A is negative 1, 2, and B is 7, 14. Find the coordinates of the point P on the line segment that AB partitions AB into a ratio of 1 to 3. All right. I'm wondering if I can do something here. Give me a second. Let me try something here. I want to see if I'm going to try something. I don't need example. All right. Now it says, I'm just going to move this over here so we still can see everything. And people, can y'all still see my screen?
Yeah.
Yeah.
All right. Let's work this one out. It says, given the points, A is negative 1, 2. So A is negative 1 up 2. I'm right here. What just happened?
Okay.
I don't have my pen on. I did. Negative 1, 2 right here. Okay, great. And B is 7, 14. 7, 14. Okay. It's going to go all the way. 1, 2, 3, 4, 5, 6, 7, and then up 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, shoot. 11, 12, maybe somewhere up here. Hey, bud, I see you. Okay. No, I'm not almost done. Okay, 11, 12, 13, 14, all the way up to here. Okay. And I'm going to draw a straight line through that. This is B and this is A. All right. Now we're trying to find on the line segment that partitions AB into, well, what's the slope? Well, that's one thing we got to do first. What is the slope? How many down
1,
and over do I need to go?
2,
And
1.
what's that?
2, 1.
So if I go
I think,
down, so that's 14 minus 2 is 12, right?
yeah.
And then 12, and then this is -1 over to 7, so that's 6. So that's 2. Yep. So good job. So rise is 2. Rise and run 2 over 1. Okay.
Mm-hmm.
Excuse me. And then so I want to say now I'm going to go for every rise. Every time I go up 2, I'm going to go over 1, right? So I'm going to go up from A, 1, 2 over 1. That puts me as part right there. And I'm going to go up again, 1, 2, and I'll put me a dot right there. Again, this is not perfectly accurate, but 1, 2, and I go over 1. That should go right there. My line should. And then up 1, 2 over 1. I don't know. But anyway, you get the point. It's because we're off the graph and I don't have an equal number of points here. But what you're going to do is you're going to partition it just like that. Okay, into 3 to 1 equal parts. And when you do that, you are going to get 4 equal parts there. And you're going to color in from starting at A of 1 or 3, however you want to do it. And then you'll have one part that's not. Let's try another one that actually fits on the thing, 8 to 10. That one would fit on that one would definitely fit. Let's try that. I'm going to take this, go here, paste it, all this down. Put this back here. All right, much better. Let's look at this one. Given A is 2, 4. So over to 2, up 4. 1, 2, 3, 4. Pen. I don't have my pen on. 1, 2, 3, 4 right here.
Yeah, not seeing your screen.
Huh? Oh, you can't?
Yeah, not seeing your screen.
Okay, hang on one second. Wonder why not. What happened here? All right, can you see it now?
Oh yeah.
All right, thank you. All right, so it says given the points A is 2, 4, so A is go over 2 and then up 4. 1, 2, 3, 4, puts it right here. Here's our first point, A. This will be A. And then it's over 8, 10. So all the way over to 8. 1, 2, 3, 4, 5, 6, 7, 8, up all the way to 10. And this is 10 up here. This is B. And this is A.
Mr. B.
Huh?
Not like your name.
Oh, I
Yes.
got you. All right. And then it says find the coordinates on the point P, draw on the directed line, segment AB, that partitions AB in the ratio 5 to 1. So that's going to be 6 parts. 5 plus 1 is 6. Plus 1 is equal to 6. Okay. So we need to first find the slope. And we know that if I go down here from 10 to 4, that's 6 moves, right? And then from 2 over to 8, that's also 6 moves. So that's a 1 slope, right? 6 over 6 is 1.
-1.
So for every time I go over, let's use screen. Every time I go over 1, I go up 1. There's a point. If I go over 1 and up 1, there's a point. If I go over 1 and up 1, there's a point. Over 1, up 1, over 1, up 1, over 1, up. Now I got to find 5 to 1. Okay, so here's 1 segment, 2 segments, 3 segments, 4 segments, 5 segments. And then my last segment is here. That's 5 to 1, right? So that's going to put me at this point right here, which is 7, 9. 7, 9. Now, she said earlier we could take, any of these points and subtract. So we're going to take point B, that's a coordinate of 8, 10. If I subtract 1 from 8, I get 7. If I subtract 10 from 1, I get 9. So that point, 8, 10, and I subtract that slope, or my new slope of 1 to 1, then I get 7, 9. And that's the point I'm looking for right there. That point, 7, 9, partition segment AB into a ratio of 5 to 1 equal parts. I'm going to do one more example, but does that make sense?
Yeah.
So step 1, plot your line segment. Step 2, find the slope and reduce it to find the new slope, and then partition your segments based off what the new slope is. So let's do one more, and I'm gonna break this out again. Escape, no, in show, discard, come over here, grab this, Control C, come over here, paste it, give me this, Control A, reduce it, move it to right there. All right, everybody still see my screen?
Yeah.
Perfecto. Okay, so now we got given points P to Q, back to P to Q again, good job. All right, so we got -3, 1, I'm gonna go blue. -3 and then down -5. 1, 2, 3, 4, 5. That's right there. I'm gonna put an X. And Q, so this is point P, and Q is 7, 0. So I go all the way over to 7. 1, 2, 3, 4, 5, 6, 7, 0. So my other point is here, and that's Q. And I just draw my nice line, which is going to be, I just draw it right through there. Okay, that's pretty good, huh? Not bad. Now, we want to find our rise over our run, which is not hard. We know that if we go up 1, 2, 3, 4, 5, so we got 5. And then if we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we actually have a 1 over 2. And again, we're partitioning in this in a 2 to 3 ratio. So that's 2 plus 3 equals 5. So we're going to have 5 equal parts based on a 1 to 2 slope. So if I go up 1, and I'm going to do this in red so we can see it. If I go up 1, I got to go over 2. So from my P value, I go up 1 and over 1, 2. That puts me a point here. Nice little X. If I go up 1, I got to go over 2 again. So if I go up 1, I got to go over 1, 2, and that puts me another point there. Then I go up 1 again, I go over 2, that puts a point there. And then up 1 and over 2, it puts a point there. Now look, my line's not perfect, but you can see that it's hitting at a certain point every time. If I go up 1, I get me right back to my start, right? So now how many segments do I have? 1, 2, 3, 4, 5 segments. And I need a 2 to 3 ratio from my P value. So I'm going to have this segment and this segment. There's 2 of them. And then for my other segment, I'm going to have 1, 2, 3. Now, this point right here, this point is going to be 1, 1, 2, 3, -3. Okay. So let's look. What is our point P? Is a -3, -5. Okay. So I got a 1 to 2 slope, and this is a rise. So I subtract that from my y value. That doesn't work either. I wonder why. Am I looking at this right? Rise. So -5 minus 1 will give me a 6. That's I don't know. I'll have to call Miss Edwards and ask her what she means by that. Sometimes it works, and sometimes, unless I'm looking at it wrong. Does anybody know? Can anybody understand what I'm trying to do here? Like, I'm trying to get to this point by just using our new slope of 1 to 2. Rise over run. X is my run value. Y is my rise value. So I should be able to take.
So if I take -1,
Is that a 4 or a 3?
yeah, that should definitely be a -4 because like negative, but it's -3 and -1, -4, and I think this should be then this one should be like -1, and it should be like 4. I don't know, probably. I'm just
Yeah, I'll
kidding.
have to ask her what she meant by that because it's not working out properly for some reason. The way she put it on the slide there. I'll text her a little bit later, but I know for a fact this is exactly how to partition a segment. This is the easy part. I just don't know her one line there that talked about how you can do it without graphing. I prefer to do a graphing because visually you can clearly see that we have a 2 to 3 segment ratio, and that puts our point at 1 to -3. All right, let's continue on. I think there's going to be another one. Yes, we get to do another one. And I'd like to give control. Well, y'all probably don't have the ability to do that.
Are you gonna post the answer key to the worksheet?
I did.
To this one?
Oh, I haven't done this one yet. No.
Yeah, I mean this one. Will
Okay.
you?
I may or may not. Should I do it or not?
Yeah.
Because I kind of have to go to Spanish Zoom.
Oh, Spanish. Who cares about Spanish?
Majority of the votes.
All right. Should I go ahead and do y'all want to see another example, or should we just end for the day?
Well, for me, I have like another question from the previous keeper.
Okay.
It's from the worksheet, like the number 13 at the back of the worksheet, not the keeper, like the worksheet that you have to print out to solve.
Okay, let me pull that up. Give me 1 second. Is that distance midpoint worksheet?
This one? Wait, not this one. The
Is it-
previous keeper.
Yeah, is it? Oh, previous keeper. Not the distance midpoint. Hold it up to your screen if you got. Do you have it or?
Yeah, I put. Let me see if I can share my screen.
Hey, I can.
I know you cannot start sharing my data, but oh, I can't actually.
Huh. Look. What is it called? What's the worksheet called? What does it say at the very top?
Distance and midpoint.
Yeah, that's the one. Yeah, distance and midpoint worksheet. Yes. Okay.
So number 13.
Number 13. Let me look at it here. Okay. So let me share this screen. Is it this one, Osauce, right here? A vertical line is drawn at x.
Yeah, don't. Yes.
What is the distance between that line and point A with coordinates -2, 1? Oh, okay. That's just a distance question, right? So she didn't use the distance formula there.
Yeah.
Wouldn't it be 3-0?
Like, how did you get to that though?
I'm not, hey, shh, son, be quiet. A vertical line is drawn at x equals 3, okay? So let's, I wonder if I can draw. I cannot draw on this. Let's go back to, y'all remember what that says. Let's go back. Share screen. I'm going to put it on this right here. Can y'all see that now? All right. So it says that the vertical line of x is 3, right? Just x is 3,
Yeah.
that's the vertical line. So that's going to, why isn't this not writing? X is 3, right there. All right. Here's my vertical line. And what was the point for A?
It was, so they said point A is 2, -2, 1.
-2, 1. So that's going to put it right here, okay? So that's the point. And what they're trying to find is the shortest distance, right? You're looking for the shortest distance. So from here, from -2, 1 to 3, 0 is not the shortest distance. The shortest distance would be having a point right here, which is 3, 1. 3, 1, right? And this was -2, 1, right? So from there, we just do our distance formula. D is equal to the square root of, was it x sub 2 minus x sub 1. So it's x sub 2, we're going to say is 3 plus 2, because it's a negative, squared, plus y sub 2, which is 1, minus y sub 1, which is 1, squared. Sorry. D is equal to the square root of 5 squared, which is 25, and D should equal 5. Is that what she got?
Well, I didn't do it because I didn't understand how to do
Oh,
it.
I put
But
the
like,
answer key for that one up, but let's look, see what she got. Let me go back to the
so
sheet here.
what I was thinking that, can we also use the one that we did that, like
Yeah. That's it.
the slope formula or something? Like we have to combine it to standard form.
Oh, I don't think you're gonna have to use that on this one.
Okay, because of we don't have the slopes in a set form yet.
Yeah, I think what you're looking for, that's the midpoint formula I think you're talking about.
No, the one that we did yesterday, that they gave us a slope and like we convert into standard form and like we use the points.
Hang on, let me go to that. So that was keeper 30, I think, right?
Yeah, just like number 11. Like, whoa, what? Even number 11.
Number 11? Oh, I got it. Okay. Ah, yeah, I see number 11 here. Round your answer to the nearest tenth. So yeah, that was that other equation we learned. That was the absolute value equation. I think that's what you're talking about. And then you divide that, take the absolute value of AX plus BY, what was it?
Yeah, so the absolute value of AX plus BX plus C.
Yep.
Then over the rad of A squared plus B squared.
Yes, that's right. But this one, let me see. All she's doing here for number 11 is the distance formula. Do you see this on here? She's saying that point A, which we're given, which is 1, 2, and it's saying that to this point, she just uses the distance formula to find it.
Oh, so we don't. Oh, that's weird. Like that.
Let me see if there's any other one. Yeah, all these, she just uses the distance and midpoint to find all that. This, I actually put this key up on the site, my blog post.
So find the distance between A and C. That's because I'm thinking. That's weird, but I think I'll just, because I thought that maybe like we use the equation of the slope, like now this one is like negative, well maybe they already gave us, this one is -1 as the slope, like the 1x, then -1 as the y-intercept. Then I don't know, I'm just a little confused about that though.
Well, all you have to do on this one, it looks like, is to just find the points, because and then I think let's go back to that keeper. 29, distance and midpoint. And it was at the end of the keeper that we learned that other formula, which is this. Okay. This is what you're talking about. Formula used to find the distance between a line and a point not on the line. Well, let's go back to right.
I think that's what you're talking about, because they said I should find the distance between point A and line C.
Yeah, now look, if I'm on here, you got to tell me then, you got to tell me what that line C is. You got to find the equation, which is y is equal to mx plus b, right? And then you convert that to standard form. So y, we can say we don't know what y is, but we do know that our slope is a 1-to-1 slope. So that's x plus, and then it looks like it's y-axis. It crosses at -1, so it's x minus 1. So y equals, that line is y equals x minus 1.
Yeah.
And then you convert that to standard form, which would be you would just move everything over, right, and set it equal to 0.
Yeah.
So what would I have to write this down? Y equals x minus 1. Is it a positive slope? Up 1.
No, it's a
over,
negative slope.
It is so it's negative x minus 1.
Yeah.
All right, and so we got x plus y plus 1 equals 0. Okay, and then it gave us the point of A, which is 1, 2, right?
Yeah.
1, 2. Okay, so now, yeah, we can put that in our equation. We can say the absolute value of, well, let's see, if absolute value of A sub x, which is 1, and then that x value is the point. So let's look at it. So A sub x, where am I at here? A sub x, so that's A is 1 times 1 plus y is 1 times 2 plus c, our c is 1, okay, divide that by, it's just the point, right? I can't, is that what the equation was? I don't forgot from yesterday. Square root of a squared plus b squared. So the square root, and a is 1 squared plus 1 squared, right?
Yeah.
All right, so I got 1 times 1 is 1, plus 2 is 3. That's 4, right?
Yeah.
So I got the absolute value of 4 divided by the square root of 2. Well, I can't leave that down there, so I got to rationalize that out. Okay, and so what I have now is I have 4 square root of 2 over 2. Well, 4 and 2, that cancels to be just 2 times the square root of 2, and that is what the answer is.
Okay.
Here, I'll write it. I can't write it out on that screen. Dang.
Yeah, I see it now. I think I see the mistake I made. I think it was towards the bottom of
Here, I'll
the
write it out
equation.
on this screen. I'll write it out right here. Let me do this. All right, so we had that line of let me pull this. Oh my Lord. What is it doing? I want to cry. All right, I want to make that bigger. Now I can make it bigger. All right, that's big enough. So we know, what was that segment? Y'all probably can't see my screen, can you? So A is 1 1 and 1 2, and then okay, got it. All right, and C. All right. So can y'all, what screen do you see, Osas?
I'm seeing yours.
I know which one, with the graph on it?
Yeah, the graph one.
Yeah, on PowerPoint? Okay.
Yeah, on PowerPoint.
Good. All right. So that line, that segment, or that line was 1, 2. So this point A was here. This is A at 1, 2. And then that segment was a -1, and it was up 1 over 1, down 1 over 1. So line C kind of cut right through there. And we're trying to find the distance from there to there. Wait 1 second. I'll be down a little bit. All right. So I know. Wait. Okay. All right. So then our equation for line C, line C equation is y equals to a -1 or negative x minus 1, okay? Negative x minus 1.
Mhm.
And our point is 1, comma 2 for A. That's A point. And then
Yeah.
yesterday we did learn that equation was the absolute value of A x sub 1 plus B y sub 1 plus C all divided by square root of A squared plus B squared. Okay. So now we just plug everything in. Well, first we have to rewrite that y equation to be x plus y plus 1 equals to 0. And we still have our point 1 comma 2. So now we can plug everything in where A and B are just 1. So it's actually what we have over here is 1 times x is 1 plus 1 times 2 plus 1, okay, all divided by the square root of 1 squared plus 1 squared, okay? And then that 1 times 1 is 1 plus 2 times 1, which is 2, that's 3. 3 plus 1 is 4. So we got 4 over the square root of 2, okay? We have to rationalize that square root of 2. And what we have is 4 square root of 2 over 2. That cancels to just be 2 square root of 2.
Okay.
And that's how that works.
Okay. So now the one that has to do with vertical line on number 13,
Number
that
13.
says x is 3, the vertical line is x is 3, and they said what's the distance between that line and point A with coordinates -2, 1.
All right. So what was the line? Oh, let me.
X equals 3.
The line is x
It's a
equals.
vertical line.
Oh, x.
Yeah.
Oh, I remember this one. Okay, so x equals 3.
Mm-hmm.
So right here we have x is equal to 3. That's going to be this point right here, and it kind of comes straight down through.
Mm-hmm.
All right, and what's the point again? I forgot.
-1, 1. -2, 1. I mean,
Oh,
sorry.
-2, 1. So that's going to put it right there, right?
Yeah.
And we're trying to find. So if you want to do it in that formula, that was
AX
value of AX
plus BX.
yeah,
AX1 plus BY1.
plus C
Yeah.
over the A squared plus B squared. Well, X equals 3. I mean, that is I guess that would be a line with a slope of, I mean, it doesn't have a slope. Its slope is infinite. You could say that, huh? No. Could you say x minus 3 equals 0? Well, we don't have a y value. So that means we wouldn't have a b value. Well, our y value is actually that point, which is -1 or -2, 1. Okay. Our c would be 3. Yeah, I don't think you can do it that way. At least not.
Okay.
I mean, you probably could, but the easiest way, Osas, would just be, well, I'm looking at my graph here. I could draw a straight line across, and where does it intersect at? You know?
Yeah, -3, 1.
No, it'd be a positive 3, 1. It intersects at 3, 1, you know? Because it is just a straight vertical line. And then you could go through that formula, the distance formula, and you will get this answer of 1, 2, 3, 4, 5.
So can you do the distance formula like how you did it with the distance formula?
You want me to do the distance formula?
Yeah, can you show how you did it? Okay.
It was distance is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, right? And that just comes straight from Pythagoras theorem, okay? So then we just plug in our points. And our points, oh, so this is maybe where is 3, 1, and negative 2, 1, okay? So this is x sub 2, y sub 2, x sub 1, y sub 1. It doesn't matter what, as long as you keep the points in the same brackets. It doesn't matter if you put, because they're squared, right?
Yeah.
So if we say, then x sub 2 is going to be a negative 2. Oh my Lord, what is that? I'm not done, son. Negative 2 minus 3, and that's squared, plus y sub 2 is 1 minus 1 squared, okay? And then d would be equal to the square root of negative 3, that'll be negative 2 minus 3 is 5, so 5 squared, and that's 0. So 5 squared just equals to square root of 25, which is 5.
Oh.
And we just counted that too, right? This was a 5 across.
Yeah.
5 blocks. So the distance is 5. If each block was 1 inch, you could say it's 5 inches.
Okay.
Any other questions from anybody? But to answer Carla, I think it was Carla or I forgot, Elise maybe. I will post the answer key. I'll do that here in just a minute. But do y'all have any other questions on what we learned today? Partitioning a segment, partitioning a line on a graph?
I have to do Zoom. I don't know how time I have to. I think I have.
Somebody, what? Who was that?
No, that I didn't. Sorry, I muted myself on accident. My friend was talking.
Sound like they were having a panic attack. I'm glad everybody's okay.
So is
All right.
3 always 3, 1?
Let's say that again, Trinity.
Is x equals 3 always like 3, 1? Why wouldn't it be like 3, 0 since it's like?
Well, like we were just saying, that's a good question. We were just saying, like, this x equals 3 right here. How do you put that in standard form of a line? That's what I'll have to research and get back with you. I don't know, when you're just given a vertical line that doesn't have a y value,
Yeah.
and it doesn't have a slope. I mean, its slope is infinite, right? How do you put it in standard form? That's the question.
Interesting. I'm thinking that, I don't know. I'm thinking that if we subtract this, like it looks like it's in the slope formula, right? We have like x minus 1, right? And like we could use it into, I don't know, I'm just trying to think of something, but I don't know. Like we could just forge a y to it.
Well, y, there is no y values. I mean, it's infinite y value. But the only thing you can do, and we know that the shortest distance between any segment is a straight line. And we know that if we're on the y-axis of 1 with this point here, then we know that we could put a point also, since y is infinite, right? Y is infinite in our line segment here of x is equal to 3. We can say, well, then it's got to be crossing point 1 on the y-axis too, right? But what if it was way up here and it was point, I don't know, negative 2, 9, you know? Well, since y, this is 9, oh my Lord, negative 2, 9, we could also say, well, it could be way up here. I mean, because either way, since y is infinite, it's going to cross that point. And so as long as you pick a point on the line, you can find a distance to it. I don't know, that might have been worse. It might have made it worse, but if they gave us that point, negative 2, 1, I mean, it could have been negative 2, 10, it could have been negative 2, negative 8. Either way, line segment or line x equals 3, that 3 is going to be at the x, but the y value for that line is infinite. So it's going to go way up on the positive and way negative on the y. And wherever a point is, you can draw a straight line to it because it's going to cross, it's going to eventually, it's going to be there. I mean, it's going to cross that point perpendicularly.
Okay.
All right. This was a shorter way to get the equation. We can go over this tomorrow if y'all have questions on it. But basically, this is your A and B here is your slope value from what the new slope value, what we learned today. It's the ratio actually is what that is. So if you have a 1-to-2 ratio, A and B, and then these are just your X values between your two segments. And this is your ratio here. This is your ratio here. And so if you work this out, it will give you exactly. So you don't even have to draw it. You don't have to draw it or graph it of what we learned all today with these. So let me give you an example. This is a 1-to-4 ratio. Points of A is -3.7 and B is 5, -9. A, B. All right, so let's go back and ratio is 1-to-4. Just writing that down so I don't have to remember it. All right, so let me clear the screen and we'll begin. So we got a ratio of 1-to-4. So my 1 will go here, my 4 will go here, my 1 will go here, my 4 will go here. 1, 4, 1, 4. Okay. My x sub 2 is 5. My x sub 1 is -3. My y sub 2 is -9. My y sub 1 is 7. Okay. So right here, these are all multiplied. So, okay. So right here we have 5 plus 4 times a -3 is -12 divided by 5 because this is added. This will be 5. Go ahead and cancel these out. So 5 minus 12 is what? 6?
That's
7?
it.
-7?
That's 7. -7.
-7. Okay. -7/5. That's a weird point. Maybe that's that. And then 1 times a -9, that's -9. And then 4 times 7 is 28. And this is 5. So that's 21, right? 21/5. And that was 7/5. So I'm going to go through this tomorrow with a couple of other examples. But just know right now how to visually and graphically do it, and then we'll work on this equation again tomorrow. So right now, I just want you to practice going through the worksheet and plotting your points, partitioning your segment, using the new slope in order to get in order to partition the segment on the graph. All right. Well, hey, other than that, y'all have a good rest of your day. And
But I have a question.
Oh, yes. Who's this?
It's Leslie.
Oh, hey.
Okay, so yesterday I was doing my USA test prep and I got distracted for 3 hours. And then now it says that it took me 3 hours. Like I haven't submitted it yet, but you know how it like times you.
Yeah.
And I know you said that we only get 2 attempts. So does that mean I can't like restart it?
Oh, I don't know, Leslie.
Or will that count as an attempt?
Hey, here's the thing. It's not graded, Leslie. I mean, how do I say it? This is your time to, since we're not really accepting grades or grading, like putting in the grade book. You're really just doing this to understand how to do it. So I'm just looking for you to complete it, first of all. And then whatever the most missed questions are for everybody, we're going to go over those after everybody's done it. Okay. So to answer your question, it doesn't matter. You can retake it. It's fine with me.
Okay.
It's not going to hurt your grade.
Okay.
I don't know how well that helped, but I hope it did. All right. Anybody else? All right. Well, I'll talk to y'all tomorrow then.
Thank you.
Bye-bye.
Bye.